All right, let me walk you through. I'm making a video, Colin, so just ignore me. Let me walk you through this little Excel file I put together here. All right, so just so you know, this data is not made up. This has come off the CDC website. This is from today. It's the most recent data available. Okay, so this data is as of now. All right, so what we're concerned with is high school, middle school, elementary school, kindergarten, and preschool children. That is this cell here. In all the United States, from 0 to 17, 300 children have died specifically from COVID-19. Now, they have some other comparisons here. Total deaths, which involves everything. I don't know what to put that. Which involves everything like accidents, cancer, diabetes, pneumonia, influenza, things, literally everything. Neglect, whatever. This is what we're concerned with. Now, in order to make this make sense, we need to have context, which is the entire United States under 18 population, which would be the same thing here. Okay, so that is 73 million roughly children. So if we're going to find out the answer to the question, like what's the probability that at least one person dies within a given sample size, what we're going to do is we're going to use a normal distribution approximation. Now, why is this appropriate? Well, health outcomes typically vary due to biological variability. And even if it's not biological, even if it is environmental, a lot of times those environmental factors are themselves chosen via biological variables like intelligence and things like that. And so I think that it's pretty safe to assume approximate normality, and then we can go ahead and use our normal tools here. So the probability of death for someone under the age of 18 in the United States is 4.1 times 10 to the negative 6. Now, just so you know what that looks like, it's kind of hard, but that's 4 preceded by 5 zeros. 1, 2, 3, 4, 5. Okay, so that's a pretty small probability. Q is the complement. That's the probability of survival. Now, we needed that to calculate the standard deviation. The sample size I chose as 3,000 because it's the size of my school, approximately. All right, so the mean, the expected amount of deaths within this population of 3,000 is actually 1 out of 100. 1 out of 100, 0.01. The standard deviation we get by doing the square root of n times p times q, and that is how you would approximate the normal via the binomial distribution. So the binomial probability statement would be the probability that x is greater than 0. Now, because we're doing a correction for continuity here, we're going to call that greater than 0.5. So we include the 1 and we don't include the 0. So the answer that I get once I run this normal distribution from 0.5 all the way to 3,000, okay, given my mean, we have 0.5. 0.5 is our lower bound, is basically our x. Okay, so we're actually coming from the left here. So up to 0.5 with a mean of 0.01 and a standard deviation of 0.11, and we're accumulating. So that's what we get here. Again, just to put that in perspective, what is that? That is 1, 2, 3, 4, 5 zeros followed by a 5. So about tens, hundreds, thousands, 10,000s, tens, hundreds, thousands, 10,000s, 100,000s, about 5 in a million chance that at least one person is going to die via COVID-19 in our school. Now, that's including 1 and 2 and 3 and 4 and 5, all the way up to 3,000. If we were going to find the probability that exactly one would die, which is most likely, it'd be even smaller than that. Either way, that's the number. It's pretty unbelievable. We only get actual numbers. Like if we talk about the size of all the students in New Jersey, which is 1.7 million. So that's 1,700,000. We finally get some numbers here. So here we're talking about a mean of 7. So we would expect 7 children in the entire state of New Jersey to die of COVID-19. And that might sound like a lot, but remember, let's compare. If we ran this number, these same calculations, instead of using 300, if we used pneumonia or even pneumonia and influenza, which is here, it'd be much higher. And I don't remember there being any sort of policy changes made for that. Not that it's an infectious disease or anything like that, but I'm just saying, keeping things in line, 182 isn't that much different than 300. I mean, if we use this number instead, I wonder what this number would be. We could do that calculation. Hopefully that made a little sense and put things in perspective. Yeah, maybe not, whatever.